Okay, so most of you guys have learned the trig ratios last year. Okay, maybe some of those who were in semester 2 did not. Okay, so I'm going to try to go through it slowly. Okay, so what you should have learned is the acronym SOHCAHTOA. Okay, SOHCAHTOA. So SOHCAHTOA. So what this acronym helps us do is to, well, it's three different equations. One for sine, one for cos, and one for tan. Okay, and then the OH, AH, O, and A represents the sides of a triangle. Okay, so we have the first one, so we have yes, the sine. Okay, so these are the three buttons on your calculators, guys. Okay, so for those who didn't learn it last year, okay, so it's the three buttons on your calculator. You can see it, which is sine, cos, and tan. Okay, so these three here. Okay, so SOH is sine, O is opposite, H is hypotenuse. Okay, next one, cos is C, or A is called the adjacent, H is hypotenuse, and lastly, tan, opposite, and adjacent. Okay, so the O, A, and H represents the sides of the triangle. Okay, this acronym, or these three formulas, can only be used for right-angled triangles. Okay, so this is for right-angled triangles only. So right triangles. We're going to learn two other formulas later in the chapter that we could use for triangles that are not right triangles. Okay, so we have a right-angled triangle here. I should have labeled these. Okay, so what I do when I do these formulas, or to label the sides, I always start with the hypotenuse. Okay, where is the hypotenuse always located?
Opposite of the right angle.
Opposite of the right angle. So we have a right angle here, which is 90 degrees. And across from that 90 degrees is always your hypotenuse. Okay, your hypotenuse is always across from the 90-degree angle. Okay, then the other two can switch. So the opposite and adjacent could switch based on the angle that you are looking at. So in this case, for this example, I put the angle here. Okay, so it's kind of, for those at home, it looks like this. And that's called theta. Okay, so theta represents the angle. It's just a symbol we use for the angle. We have a whole bunch of different ones you can use from the Greek alphabet. So we have beta, theta are the two most common ones. Okay, it represents the angle. So if we are looking at this angle or using this one, then we can label our opposite and adjacent from here. So I always label the hypotenuse first, and then I label the opposite angle second. Okay, so the opposite side is opposite of the angle that you're looking at. So in this case, this is the angle that we'll be using. So the side across from it, or opposite of it, is called our opposite side. Okay, so across from the 90 is hypotenuse. Across from the angle that you're using is called the opposite side. Okay, and then lastly, whatever remains is our adjacent side. Okay, so this is our last one we label adjacent. Okay, what does adjacent mean?
Beside.
Sorry?
Beside.
Beside or next to. Good. So adjacent means beside or next to. So the adjacent side is the side that is next to the angle that is not the hypotenuse. Okay, so adjacent meaning beside or next to. Okay, so those two sides can change. So if I give you another example here. So say I was using this angle in this corner. So I put a theta there. So my hypotenuse will still be across of the 90-degree angle. So H is our hypotenuse. Okay, where is the opposite side now? Where is the opposite side?
The bottom side.
Good, here. So the opposite of the angle this way, so this would be our opposite side. Okay, and then the last one is your adjacent side. So depending on where your angle is, will determine your last two sides. Your hypotenuse never changes, it's always across from the 90, but our O and A can switch based on the angle that we are using. Okay, so these are the three formulas will be used. So depending on what is given in the question, will determine which one we use. So if we have the opposite and hypotenuse, if it's given to us, then we'll use this formula here. If we have the opposite and adjacent, then we use the tan formula. So these three, they all do the same thing. Okay, they calculate angles or sides, but we use each one based on what is given in the formula. Okay, so something new to you this year is called reciprocal ratios. Okay, the reciprocal ratios. So we have cosecant, secant, and cotangent. And it's just the flip version of the first ones. So if we flip these two, okay, if we flip the opposite of hypotenuse, we get cosecant. If we flip the hypotenuse and adjacent, we get secant. And if we flip these two, we get cotangent. We won't be really dealing with these much. Whenever we use these, we end up just flipping it back to these ones. Okay, so we'll be mostly focusing on this ones. Again, if we have something in this form, we're just gonna flip it to this form, okay? And then another way to look at it, cosecant is the inverse of sine, the reciprocal of sine, so we flip sine. Okay, secant the same thing. And lastly, I don't know why these little upside down question marks are. They're supposed to be equal signs. And the last one, cotangent, if you flip tan, that's what gives you cotangent. Okay? And lastly, remember that you learned in grade 8 and 9 and 10, anytime you have two sides and you're looking for a third side, we use Pythagorean theorem. Okay, so anytime you are given two sides and you're looking for a third side, we could use the Pythagorean theorem. Anyone learn anything other than SOHCAHTOA? Okay, is that what you used, the acronyms? I used to have a teacher at my old school, very old school, DY, just do a whole formula, he just the whole story. And the way he used to say it was SOH would be sign on the highway, I don't know why. And then CAH, so the cosine was cozy at home. What was the last one? TOA was the tan on the arm. So it was just something different. But you guys all learned SOHCAHTOA, right? Okay. Okay, so remember Pythagorean theorem. C is your hypotenuse, and the A and B are the other two sides. It doesn't matter which one is which. Okay, often I do this as my base, but remember C is your longest side of your hypotenuse, and A or B are the other two sides. And again, this can only be used for side lengths and not angles. Okay, and again, for right angled triangles only. Okay, so SOHCAHTOA, Pythagorean theorem, can only be used for right-angled triangles. Okay, so a couple other terms that we need to know. Okay, again, this should have been taught to you last year. You guys learned these two? Did you guys learn these two? No? Yes? No? 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 Okay. Okay, so there's two terms. It's called angle elevation. So sometimes in a word problem, you'll see these in word problems only. They'll say the angle elevation up to a tree is 50 degrees, okay? Or it'll say the angle elevation up to the airplane is 75 degrees, okay? So the angle elevation is from the ground, or the horizontal, up to an object, okay? So if you think about, if I'm standing here and I'm looking up to, like, say, a plane, okay? So I don't know if I'm in the video. So if I'm standing here and I'm looking upwards, say towards a tree, the angle from me to the top of the tree is my angle of elevation. Okay. In this case, I've used the butterfly And what happens is here, we could create a right triangle with a 90 degrees. Okay, then we have the angle of depression, which is the opposite. Okay, so it's when you're looking down, say looking down at an object. So say I'm on a cliff. Okay, maybe I'm on top of the stairs. Okay, and I'm looking down. Okay, the angle from me downwards, okay, from the horizontal downwards is called our angle of depression. Sometimes angle of elevation is called angle of inclination. Okay, so sometimes I might say, because it's the incline, okay, so they'll say angle of inclination, so it's the same thing. Okay, so the same thing if you see those two words. If at home you guys are having any issues seeing any of the words, or you didn't print this out, so you're not following along, please let me know. Okay, now we're going to go through a couple examples, and each example I'm going to show you how to solve for each side and each angle. Got this?